गुड आफ्टरनून रिस्पेक्टेड प्रोफेसर्स एंड गुड आफ्टरनून ऑल माय क्लासमेट। मेरा नाम इक्षा द्विवेदी है, रोल नंबर 24041। क्या आपके मन में कभी ये क्वेश्चन आया कि थायराइड हार्मोन T3 एंड T4 को ही क्यों कहा जाता है, नॉमेनक्लेचर की शुरुआत T1 T2 से क्यों नहीं की गई? तो इसका आंसर आपको मिलेगा इन माय वेरी इंटरेस्टिंग पिचाकुचा टॉपिक, दैट इज बायोसिंथेसिस एंड एक्शन ऑफ थायराइड हार्मोन। Thyroid gland is composed of closed follicle lined by cuboidal epithelium filled with colloid. Major thyroid hormone are T3 tetraiodothyronine, T4 tetraiodothyronine. Reverse T3 is secreted in a small amount which is biologically inactive. Calcitonin secreted by parafollicular cell is involved in calcium homeostasis. Sodium and iodide are transported from blood capillary into the follicular cell by sodium iodide symport. Again, the concentration gradient by sodium potassium ATPase. This process of concentrating iodide ion into the follicular cell by is called iodide trapping. Now, iodide ion are transported across the apical membrane into the cavity of follicle by chloride iodide antipode called pendrin. Now, iodide ion are oxidized to iodine with the help of enzyme peroxidase and H2O2 present in the apical membrane. Thyroglobulin, which is a large glycoprotein produced by endoplasmic reticulum and Golgi bodies, has 70 tyrosine amino acid which bind with the iodine at the 3' position to form monoiodotyrosine and further at the 5' position to form diiodotyrosine MIT and DIT. Now, monoiodotyrosine bind with diiodotyrosine to form T3, which is 35% in the colloid, and 2 molecules of diiodotyrosine combine to form T4, which is 7% in the colloid. Cell of apical membrane produce pseudopod, which engulf colloid by pinocytosis in the presence of Mechelin receptor present in the apical membrane. Lysozyme fuse with the vesicle, where proteolytic enzyme break peptide into MIT, DIT, T3 and T4. T3 and T4 are transported to the blood by capillary plexus, while DIT and MIT are turned back into the cavity of follicle and get deiodinized by deiodinase enzyme. T3 is 7% in the circulation and T4 is 93% in the circulation, because T3 is more active as compared to T4. 0.05% of T4 and 0.5% of T3 are transported in the circulation in free form, which is biologically active, while 99.95% of T4 and 99.5% of T3 is circulated in bound form. Thyroxine binding globulin bind 70% of T4, thyroxine binding albumin bind 10% of T4, and thyroxine binding prealbumin bind 10 to 20% of T4. In deiodination, 40% of T4 is converted into T3 and 60% of T4 is converted into reverse T3 by deiodinase enzyme and further deiodinized into DIT and MIT. In decarboxylation, small amount of T3 and T4 are metabolized into triiodothyroacetic acid and tetraiodothyroacetic acid. In conjugation, glucuronide and sulfate are formed, which are transported by a bile duct into the intestine and further into the transported by the feces, and a small amount is excreted in the urine. T3 and T4 enter the cell membrane by carrier-mediated ATP-dependent transport, where T4 is converted into T3 and T3 interact with the thyroxine hormone receptor, which is bounded as heterodimer with retinoid X receptor in the proximity to the gene. This gene increases the protein production. Thyroid hormone increases the cellular activity by increasing number and activity of mitochondria, increases the ATP formation, energizes the cellular activity, and hence increases the basal metabolic rate of the cell. Thyroid hormone increases the active transport of iron into the cell membrane and makes it leaky for the sodium ion. This increases the sodium potassium ATPase activity and increases the heat production in the cell, increases the BMR, and hence decreases the body weight and cause the body weight loss. Thyroid hormone increases the protein production by increasing growth hormone and somatomedin. It increases the bone development, increases the teeth development, causes the growth and maturation of the tissue. T3 is essential for dendritic development and myelination of the neuron. Mental retardation is the striking feature in case of thyroid hypothyroidism. As the BMR increases, so the fuel requirement increases, so the glucose is absorbed from the GIT. Glycolysis, gluconeogenesis occur, insulin production increases, glucose uptake and utilization increases. As the enzyme increases, so the vitamin and coenzyme also increases because they are the part of enzyme. As thyroid hormone increases, the cholesterol, triglyceride and phospholipid decreases, but the free fatty acid increases. In physiological limit, the thyroid hormone has anabolic effect which increases the protein production and leads to positive nitrogen balance. In high amount of thyroid hormone, it has a catabolic effect which leads to negative nitrogen balance in the body. As the BMR increases, so the metabolite also increases, which causes vasodilation. Increased blood flow causes the increased cardiac output and heart rate. As the SBP increases, DBP decreases, so the pulse pressure increases, but the mean arterial pressure remains the same. Adenylyl cyclase and calcium uptake increases, which causes the increased force of contraction and hence increases the heart strength. Thyroid hormone increases the utilization of oxygen by increasing the resting respiratory rate, minute ventilation, and ventilatory response to hypercapnia and hypoxia. These actions maintain the normal oxygen level when O2 utilization increases and normal CO2 when CO2 production increases. Thyroid hormone is essential for development of nervous system up to 1 year. It increases alertness, wakefulness, responsiveness to stimuli, hunger, awareness for hunger, memory and learning capacity. It increases the speed and activity of peripheral nervous reflex. Thyroid hormone increases the appetite and therefore increases the food intake. It increases the rate of secretion of digestive juice. It increases the motility of GIT. Excess thyroid hormone causes diarrhea and decreased thyroid hormone causes constipation. In male, decreased lack of thyroid hormone causes libido and excess causes impotency. In female, lack of thyroid hormone causes menorrhagia, that is increased excessive menstrual bleeding, polymenorrhea, that is frequent menstrual bleeding, irregular menstrual bleeding, absence of menstrual bleeding, that is amenorrhea. Oligomenorrhea is seen in case of hyperthyroidism and decreased libido is seen in case of hypothyroidism in female. Thyroid hormone increases the growth hormone and decreases the prolactin. It also increases the adrenocortical secretion of cortisol. Estrogen and androgen ratio increases in male, which causes breast engorgement in male, and it increases vitamin and parathyroid hormone. No matter how much we say about the effect of thyroid hormone, it is never enough. Thank you.